Welcome to video lesson number 11. This is our last lesson in our grade 10 chemistry series. And today we're going to be looking at acids and bases and what the pH scale is and how indicators work and things like that. So first of all, acids and bases. You've probably heard those terms before, specifically acid. When people talk about like lemons or vinegar, they say it's an acid or stomach acid. And so what are acids and what are bases? What are the things that really characterize them? Okay, and it has to do with what types of ions they produce when they're dissolved in water. So acids produce hydrogen ions when dissolved in water. Okay, so it's going to make H plus in the water. So chemical formulas, when you're recognizing acids based on a formula, chemical formulas have hydrogen as the cation in the equation. So as the positive half, okay, you have H plus as the ion in the equation. So you'll see it, they'll generally start with hydrogen. So some examples would be HCl, that would be hydrochloric acid. Another one would be H2SO4, that's sulfuric acid. So hydrochloric acid is the type of acid that is in your stomach. Sulfuric acid, that's also known as battery acid. But there's lots out there. So hydrofluoric acid, hydrobromic acid. We talked about nitric acid in one of our previous examples. So anything that starts with hydrogen generally is going to be an acid because it's going to produce H plus ions when you put it in water. Bases are sort of the opposite. So rather than producing hydrogen ions, they produce hydroxide ions. So bases produce hydroxide ions when dissolved in water. So hydroxide ion is OH minus. Okay, and the chemical formulas therefore also include hydroxide as the anion. So chemical formulas have hydroxide as the anion, so the negative half of the reaction. So some examples would be magnesium hydroxide or potassium hydroxide or calcium hydroxide, sodium hydroxide, so on and so forth. Now you may notice that if we took an H plus and an OH minus and we put them together, that seems like it would make water. And you are completely right. So when you mix acids and bases together, if they're in equal proportions, then they'll make water and be neutral. So we'll talk a little bit about neutralization reactions in a minute. But we use something called pH to measure the acidity or basicity of acids and bases. So pH, the value, or the pH value, sorry, I should write that in to make it nice and clear. So the pH value of a solution is a measure of the concentration of hydrogen ions. Okay, the pH scale compares the acidity or basicity of solutions. So it gives us a number to categorize the solution by that we can compare then to other solutions with similar or different numbers. So the pH scale goes from 0 to 14, with 7 in the middle being pure water. So thinking again back to if you have equal amounts of hydrogen ions and hydroxide ions, that gets you H2O right in the middle. If you have more hydrogen ions, then you work towards this acidic end. If you have more hydroxide ions, then you'll be looking up towards the positive, or the higher value end, where bases are. So on this picture, you'll see there's a few different common substances listed there to kind of show you what types of pHs they are. And we're going to do a little bit of an activity next, where you're going to try to categorize different substances as either an acid, a base, or neutral. So I'll do a couple of them for sort of an example, and then you can finish it for practice. So lemon juice has a pH of 1.7. So looking at your diagram, everything between 7 and 0 is an acid, and everything between 7 and 14 is a base. So if it has a pH of 1.7, then it's falling right in here, which makes it an acid. Blood, 7.4, okay, is greater than 7, so it's just on the side of 7. So it's slightly basic. Just barely, but a little bit. Milk of magnesia, this is something that you would take if you had heartburn, and it's a medicine like Tums or Rolaids. So it has a pH of 10.5. Again, that's between 7 and 14, so you're looking at that's a base. Okay, and then there's a few others for you to try. On this side, you're going to do it based on the formula or the name. So potassium hydroxide, if it contains hydroxide, it's a base. Versus if you look at this one, this is chloric acid, HClO3. Okay, if it has an H at the beginning, like we talked about just a minute ago, that's going to be an acid. So take a moment, you can pause the video and finish up those last few practice questions, and then you can come back when you're ready to move on. So what does an indicator do? What is an indicator and why is it useful for something? Okay, an indicator is a chemical substance that is one color in an acid and a different color in a base. So it's usually something that you would add, 2 or 3 drops of an indicator to a substance and see what color the indicator changes or becomes to tell you whether you have an acid or a base or a neutral substance. Okay, so an indicator can be used to determine if a solution is an acid or a base. So below here at the bottom, we've got a list of the most common indicators used in chemistry, with phenolphthalein and bromothymol blue, and maybe methyl or universal indicator being sort of the top three that are used really commonly. In grade 11, you'll definitely be using phenolphthalein a lot. And it says the color that the indicator is for each condition. So whether it's in an acid, a base, or in pure water, so this would be in a neutral condition. You'll notice that when you look at it, usually indicators have one color change for one side, so either a base or an acid, and then another color that they are in both neutral and the other option. So if we look at phenolphthalein, it's colorless in both acidic and neutral conditions. It only changes color to pink in a base. For bromothymol blue, we've got yellow in an acid, and then it's blue in either a base or in neutral conditions in water. So it's only going to change color sort of one time. There are some exceptions to this, like universal indicator is actually a mixture of multiple indicators put together, and it does a bit of a rainbow effect based on the conditions, but most of them will be just one quick color change. So you're going to use this table to complete the next little activity. So here we've got some lab data on 3 unknown substances. So unknown substance A, in phenolphthalein, it turns pink. Bromothymol blue, it turns blue. So checking with your table here, phenolphthalein is only pink in a base. So this is telling us it's probably a base. Bromothymol blue can be blue in both basic and neutral conditions. So base or neutral. So that means that your unknown substance A is going to be a basic solution. Unknown B is colorless with phenolphthalein. So phenolphthalein here is colorless in an acid and colorless in neutral. So it could be acidic or neutral. And the bromothymol blue is blue. So bromothymol blue is only blue, is blue in basic conditions or neutral. So here basic or neutral. So the only common possibility is that this substance is neutral. And finally, with unknown C, we have phenolphthalein is colorless, which we already determined meant that it was acidic or neutral. And the bromothymol blue is yellow, so bromothymol blue is only yellow in an acid. So they both agree if we say that this unknown is an acid. So you can often use a couple of indicators to figure out pretty closely what a specific substance is. So when we mix acids and bases together, okay, this is known as a neutralization reaction. Okay, because you're taking acid and base, you're putting it together and producing something that has a neutral pH. Okay, as a result of this, when you're neutralizing, remember we had hydrogen ions from the acid and hydroxide ions from the base, you're going to be producing water as one of your products. So water, H2O. When you take H plus and you add OH minus, you put them together, you're going to get water. The other product of the reaction is usually an ionic compound. Not exclusively, but for us in grade 10, definitely always going to be an ionic compound. We also call these salts. So ionic compounds are also referred to as salts. So let's do an example. What happens when you mix sodium hydroxide with hydrochloric acid? Sodium hydroxide, sodium is a metal. This is an ionic compound. We've got Na plus, hydroxide is OH minus, crisscross rule, it's a 1-to-1, so we're going to get NaOH. plus hydrochloric acid. You can check on your list of acids on your periodic table, is HCl. Neutralization reactions are a form of double displacement. Okay, so they're like double displacement, where this hydrogen and the sodium are going to be switching places to produce NaCl, so there's your salt compound, your ionic compound, plus water, so H2O. You can kind of think of this as like HOH in terms of the double displacement idea behind this, but we would normally rearrange that and write it out to be H2O. So a couple other practice questions here. We've got NH3, so this is nitric acid, plus magnesium hydroxide. So your magnesium and your hydrogen are going to swap places to get magnesium nitrate and water. Now we need to balance this, so we have 2 nitrates on this side, only 1 here, so we put a 2 there. That gives us 2 hydrogens, plus another 2 is 4. So 2 times 2 is 4. That's going to balance out the hydrogens and the oxygens. The next one here, we've got sulfuric acid plus potassium hydroxide. So the potassium and the hydrogen are going to switch places to give us K2SO4 and water, H2O. Again, we want to balance it. We have 2 potassiums on this side, only 1 here, so we'll put a 2 there. That gives us 2 hydrogens plus another 2 is 4 total. So a 2 in front of that gives us 4, and then 2 oxygens and 2 oxygens. So you start to see a pattern. So the general formula for a neutralization reaction is going to be HX, which is going to represent your acid, so something with an H stuck to it, plus BOH, so that's representing your base, so some metal with OH stuck to it. Okay, you're going to get the double displacement happening where you're going to form water, H2O, plus, in this case, BX. So B is your metal, X is a non-metal, forming an ionic compound. So that's your water and salt.